In this demonstration, I'll show you how to fully analyze the standard and factored form of a quadratic equation. This is question number 1. The question is asking us complete the table below. They want us to go from standard form to factored form. They also want us to find the direction of opening, y-intercept, x-intercept, and axis of symmetry. The easiest of these 5 things that they're looking for is the direction of opening. To find the direction of opening, you have to locate the a term in your equation. In our case, the a term is 3x squared. Notice that 3x squared is positive. And because it's positive, it's going to open upwards. So we're going to write down up. If it were negative, it would be down. The next easiest thing to find is the y-intercept. To find the y-intercept, you set x equal to 0. So let's do that. To find the y-intercept, y is equal to 3 times 0 to the power of 2 minus 18 times 0 plus 15. Notice that this will go to 0, multiplying this term out goes to 0, and we're left with positive 15. So our y-intercept is at 0 and positive 15. In order for us to find the x-intercepts and the axis of symmetry, which relates to the vertex, we need to convert this equation into factored form. Now, to convert it into factored form, we first have to common factor the equation itself. Notice that in the equation, there's a 3 in common in all 3 of these terms, so we can factor that out first. Let me show you what I mean. We have y is equal to, and if we factor out the 3, we end up with x squared minus 6x plus 5. Essentially, what I've done is I've divided each of these 3 terms by the number 3. Giving us the following. Now what we can do is find 2 numbers that multiply to 5 and add to negative 6. What 2 numbers multiply to 5 and add to negative 6? The 2 that I'm thinking of are negative 5 and negative 1. Because look, negative 5 times negative 1 gives us positive 5, and negative 5 plus negative 1 gives us negative 6. So I'm going to open up 2 sets of brackets where we have x in both, and I'm going to place this minus 5 right here and this minus 1 right here. There you have it. This equation, the standard form equation, now is in factored form. And I'm going to write that in this slot. 3 times x minus 5 times x minus 1. Now we need to find the x-intercepts. And the way we find the x-intercepts are 2 ways. You can use the quadratic formula, which is a lot of work, or we can set this equation equal to 0. If we set this equation equal to 0 and start off by dividing both sides by 3, we end up with 0 is equal to x minus 5 and x minus 1. Notice that by dividing both sides by 3, it cancels out on the right side, and on the left side, it goes to 0. Now, we can set both of these brackets equal to 0, and this gives us x is equal to positive 5, and this gives us x is equal to 1. These 2 numbers represent the roots for this equation. So our x-intercepts occur at 5 and 0, and positive 1 and 0. Lastly, we need to find the axis of symmetry. And to do that, we take this 5 and this 1, we add them up and divide by 2. Essentially, we are finding the average. So 5 plus 1 divided by 2 gives us 6 divided by 2, which is 3. Therefore, the axis of symmetry is 3. Now, of course, we can take this a step further and find the vertex. To find the vertex, we would take this number, place it into any of these 2 equations, and that will give us the y-coordinate of the vertex. So let's do that as well. 3 bracket, I'm going to put this number into here. 3 times 3 to the power of 2 minus 18 times 3 plus 15 using our calculator. 3 bracket 3 to the power of 2 minus 18 bracket 3 plus 15, and that gives us negative 12. So that represents the y-coordinate of the vertex, and there you have it, a completed table, and that is how to fully analyze the standard and factored form of a quadratic equation. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, visit our website at studyforce.com. We're an online service for students seeking free homework help. See you soon.